This week, it's Security Weekly Virtual Hacker Summer Camp. In our first segment, we welcome John Loucaides, the VP of Research and Development at Eclypsium, to talk about putting zero trust in your devices and some very interesting vulnerabilities that were discovered by the team. In our second segment, we talk enterprise security news, discussing Eventanium offering a new cybersecurity service through a partnership. CyberArk is launching an open source shadow admin identification tool for Azure and AWS. ThreatStack Cloud Security Platform is being extended to gain observability into AWS Fargate. Polarize announces a SaaS-based security platform, and more. In the final segment, our dear friend and host of Security and Compliance Weekly, Jeff Mann, will talk about mapping the MITRE ATT&CK framework to the PCI DSS standard. So stay tuned for all that and more on this episode of Enterprise Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where we talk security vendors and aren't afraid to name names. It's Enterprise Security Weekly.
Today, every business is a digital business. Most of us are migrating workloads to the cloud, adopting DevOps tools, rolling out RPA software, and supporting a remote workforce. While opportunity is great, so is the risk of advanced cyber attacks. Many high-profile breaches start with a compromise of privileged credentials. CyberArk is the #1 leader in privileged access management. Talk to CyberArk today to secure privileged access for humans and machines across hybrid and cloud environments and on endpoints. Learn more at securityweekly.com/CyberArk and stay one step ahead of the attackers. Detecting and responding to threats in the cloud is harder than doing it on-prem. Even when you do have the visibility you need, legacy security workflows weren't designed for the speed and complexity of cloud environments. Cloud-native security solutions from ExtraHop are purpose-built to spot threats across the hybrid attack surface, provide detailed investigation steps, and help you automate response. Request your 30-day free trial at securityweekly.com/ExtraHop. Welcome to episode 193 of Enterprise Security Weekly for August 5th, 2020 even. I am your host, Paul Asadorian, joined in studio by Mr. Matt Alderman.
Wow, this is 3 days in a row. And we didn't finish the Macallan last night, so we figured we'd put a dent in it tonight.
That's right. This is the first time we've done ESW in studio at night.
Mm-hmm.
Yeah. We've done it at conferences.
We've done it at conferences, but
night.
the first time we've done it in studio at night. Yeah.
It's got a nice vibe. I kind of like it. My wife will hate me if we want to move the time.
Oh, yeah. 2 nights in a row? No, she'll kill you.
Yeah, that would be bad. Forget I even said that. Make sure you visit securityweekly.com/webcast to see what we've got coming up. Talk with Todd Beardsley from Rapid7. Ask questions about the findings from the National Internet Cloud Exposure Report on August 13th. Which is going to be a lot of fun. Todd has a project where he scans the entire internet and tells us about the things that he learned. Also, learn how to create and run a conference from the geniuses behind Layer 8 and Wild West Hackin' Fest on August 19th. Our next technical training on August 27th will teach you about boothole, SIG-RED, and SMB bleed, best practices to prioritize and remediate now. Is that Eclypsium's?
No, that's Vulcan Cyber is doing that one.
Vulcan Cyber is doing that one. Yeah. Oh, okay. Interesting. That's awesome.
Boothole's going to get a lot of coverage. We covered it on ESW on Monday, and we're going to get it tonight, too.
That's awesome. SecurityWeekly.com/on-demand will let you view our previously recorded webcast. Lots of good stuff coming up. I am very excited to welcome to Enterprise Security Weekly John Loucaides, the VP of Research and Development at Eclypsium. He's got extensive history in hardware and firmware threats from his experience at Intel Corporation and the U.S. government. He's joining us today. I think we're basically talking about boothole is what we're coming down to. We'll get into
it.
Yeah,
like everyone else.
John, welcome to the show.
Thank you very much for having me. It's good to be back.
Folks, please visit securityweekly.com/Eclypsium to register and get a trial of the software, especially after you hear this segment. Every time I talk to John, I'm like, we really need that. Like, that is a huge hole in our security programs, and we're going to dig into basically some of those newer holes and exposures. And one of my first questions for you, John, when we were talking earlier was, did you name it boot hole or did someone else?
It wasn't me personally, but I did get a big kick out of it, so I guess I'm partly responsible. But the name I actually found out after everybody else had talked about it, and I just couldn't stop laughing.
Yeah,
so,
it's really awesome.
You understand.
Mm-hmm.
Well, because now my next question is going to talk about like some of the terminology and how things interact, so we can talk about boot hole, right? And I needed a refresher because you go across so many different platforms, and you're like, wait, where's the BIOS? But it's not BIOS, it's you. So explain, I guess, John, the relationship between what we term as BIOS, UEFI, the bootloader, some of the different bootloaders. Some of you might remember Lilo, Grub 2, right? And then the secure boot mechanism. I think is a really good place to start.
I also want to know what you guys would have named it as we talk about this, because that's always a fun one. The name and the logo, always entertainment value right there. What's going on here is the new version of BIOS, so to speak, right? The Unified Extensible Firmware Interface, UEFI, includes as part of the spec this idea that you can verify signatures on a piece of code before you execute it. And that's the secure boot process. If you think back to
so wait, John, so
good old days.
BIOS is old, so we'll call it UEFI because it's
UEFI now,
right. Most systems today are using UEFI, which before we're calling the BIOS, but UEFI on modern like PCs. We'll leave a lot of the embedded IoT stuff aside for the moment. I do want to come back to that though. UEFI calls the bootloader. The bootloader boots the kernel.
You got it.
Right.
And if you think back to the older sort of MBR-based boot before UEFI, you had a similar attack, right? You had this bootkit attack where you would infect the MBR, and you get in before the kernel. If you get in before the kernel, you can do all sorts of stuff. You can change the kernel while it loads, and that's where these traditional sort of bootkit attacks came from. The purpose of secure boot in the UEFI spec was to try and guard against this sort of thing, and they do that by checking a signature. There are other protection mechanisms as well. You may have heard of measured boot. There are different things used with core boot, but the idea is a signature check. And just like any signature mechanism, similar problems come up with revocation in this boot hole thing that you may have seen with software signing and other sort of signature-based mechanisms.
Right. So basically, the motherboard has on it a UEFI firmware. So basically, there's an embedded device inside of your motherboard that's running UEFI, right?
You got it.
And it's in secure boot, it's validating with a cryptographic signature that the bootloader is what it says it is, correct?
Yep. Think about when you just turn on the computer and the processor boots from a reset vector, and that stuff that's already mapped into memory there is UEFI. At some point, it goes to the disk and it wants to go load something from there, and that's the bootloader. And what UEFI did in the secure boot feature was that they introduced a signature check as they go read it off the disk.
And that's usually the default, right? Because when many of us that build Linux and operating systems really don't matter at that point. The hardware that you get running UEFI is like, I only want to boot via secure boot and be able to cryptographically check that. If your kernel or bootloader, right, or I should say bootloader, is not equipped for that, you'd go into UEFI and you would disable secure boot, right? Sometimes I've done that in just troubleshooting process. I'm like, because I installed it and the bootloader's not coming up, and it's a brick until I can fix this problem. And one of the troubleshooting now, I'll go disable secure boot, see if that fixes it.
And that's one of the problems that you can run into when you're trying to fix this boot hole issue. If the thing doesn't get updated properly, if you kind of reverse the order and you revoke the certificate before you've actually updated the grub bootloader, you can get yourself into that situation. And that's the way that you would fix it. You sort of push the F2 or escape or F12 or whatever it is.
Or
for your
delete. Or
computer.
I hate that. So why can't they
that
standardize
annoying
on that?
thing
Right?
that you have to get into.
Yep.
Yeah. Go in there and find secure boot in there somewhere, and it'll have a way to turn it off most of the time.
Now, John, is the vulnerability in the ability to replace the bootloader or the ability to bypass signature checks in the bootloader, or a combination of both?
Right. That was my question. Like, is it in UEFI? Is it in the bootloader, or some combination? Right. Yeah.
The actual bug, and this is actually something that a lot of folks tend to misunderstand because it's kind of a nuance. What's going on is that there is a buffer overflow in the grub bootloader, and that buffer overflow comes in the configuration file. So if you wanted to stick a payload, you'd put it in the configuration file for grub. And when you exploit this buffer overflow, you're running arbitrary code. But the reason that this issue isn't just limited to systems that have grub on it is because grub has a signature on it, and that signature will be respected by almost every machine by default. And that default signature check is built into UEFI. And so that's where the real update has to come, in the form of a signature revocation, so that that version of grub that's vulnerable won't be something that is allowed to run anymore.
So
Does that make sense?
Yeah. So let me try to dumb this down for all of us, because I'm the dummy in the room here. What you're doing is the vulnerability in grub allows you to inject something into grub, but because grub's signature is valid, UEFI doesn't realize that grub has been hijacked and allows it to load and run any of this arbitrary code because of the buffer overflow. Is that close?
And that is exactly right. That is also why, even if you don't have grub on your system today, if an attacker has control of your system, even for a little while, and drops grub onto it, they can now bypass even more security protections that are built into the kernel in most of these operating systems that you're running today, like Windows 10.
Yeah, so I get on a Windows 10 system, and I basically boot that with grub.
You can.
Right.
And in fact, that's how dual boot already works,
Right.
You just drop that in there as an attacker, and now you control underneath the hypervisor that's providing the separation for something like credential guard, and you can bypass those protections now too.
But I can not just boot any operating system on the hardware. I can inject code before the kernel boots.
Exactly.
Right.
Yeah.
Exactly. So I can still get to the point where you're running Windows or whatever it is you would have been doing, but I can inject stuff in before it ran, so that I can actually bypass something that otherwise would have been protected.
So are there two fixes required here to fix this? One
Yes,
is,
there are.
okay, so one, you have to fix the grub overflow and revocation issue, but then also UEFI has to be able to understand certificate revocation to grub so it doesn't trust it, right? So this is kind of like a two-step fix, right?
Right. Think of it as there's a problem in grub and you need to fix grub. And then you want to do that first, because if you get this wrong, this gets really interesting. But that's just step one. And you notice that if you just do that step, your system's still technically vulnerable. I can drop that vulnerable version of grub back. Even after you update it, sort of like I can undo the update, if you will, and that'll work. If you want to make that not work, which is what would close down the vulnerability, you have to add a whole bunch of stuff into the revocation list that actually prevents those versions of grub from running on a secure boot system.
In
That's
UEFI.
a firmware update.
You have to update your UEFI.
Yes. Now, it's not necessarily a full firmware update like you might have seen with a BIOS update or something like that.
It's just a revocation
list. It is something that actually persists in the firmware.
But if you mess up the revocation list, you basically, your system's not...
You could lock yourself out. I mean, you literally could lock yourself out.
You're where I get to a lot of times with IoT devices, right? You've got all the stuff on there, but you can't boot it because you screwed up the bootloader or the firmware or the UEFI or embedded system. It's usually all in one, right? I think as we
exactly. So this is the crazy part, right? And for me, I got into this space because it was so interesting to me that all of the stuff you might have worked on kind of builds up upon this foundation of things that happened while the system was booting. And when you deal with problems in this space, a lot of times either there aren't fixes or the fixes that are available might be broken. And you get into this state where, for example, the first couple of fixes for most of the Linux distros actually weren't updating grub properly, and the right partition wasn't actually getting updated. So you had, there was a great phrase, unsuccessful reboots in one of the advisories. And that sort of idea of unsuccessful reboots is kind of terrible if you're actually trying to do this.
Yeah,
Right.
and add to the concern now, potentially, right, is I have a bunch of remote workers that are at home, and I got to try to update all these potential remote systems, but they're remote. So if the machine doesn't come back online, how the heck do you get them fixed?
It's a great,
It's a bad day.
Yeah.
A bad
it's a great
time
point.
for that.
It's why oftentimes the UEFI, what is it in Apple? Apple uses a different.
They also use Apple EFI, same
EFI.
idea.
Yeah. Right. It's very similar, right?
Mm-hmm.
But it's why most people don't update it, because if you push out an update to update the firmware on the actual hardware, on the system, that could be really detrimental. And if everyone's remote, I mean, when you work with these issues, typically you have physical access to the machine, and you can do some different tricks maybe to get it back, right?
Yeah, even if you do have physical access, doing it on enough machines becomes a real problem for people,
Yeah.
right?
Yeah.
If you deploy this out to hundreds or thousands of machines and, a percentage of them breaks, this is going to be a bad day.
Right. Well, I mean, the fix is you got to get in there in the BIOS or the UEFI, right, and point it to a USB or external thing that will boot, and then use that to maybe mount your drives and do the update.
Or go
right?
turn off secure boot like you were talking about, which usually involves walking up to the machine and pushing the button right at the right time.
Yep.
It's terrible. But there's actually something worse that can go wrong here. So we're all talking about just the first stage. Remember, there's 2 stages of fixes, right? The fix to grub can break on all of these different interesting ways that are bad enough. And it did happen. Like that's the worst part about this one, is that most of the Linux distros actually had that problem. I believe most of them now have updated their update packages so that the new updates won't cause that problem. But that is definitely something you're going to want to test if you're using this in live infrastructure, especially if it's on a bunch of machines. But there's another problem too. That bit doesn't actually close down the vulnerability. It just makes it so that you won't be broken when you do close down the vulnerability. The actual fix is to prevent that old version from working. And that's an update that gets stored in firmware in the form of this revocation list. That has had problems too. Not necessarily this time, although I suspect we'll hear about that soon too. But the last time that Microsoft tried to deploy this through Windows Update, it only had like 5 hashes in it. And it was for a very specific Kaspersky rescue disk that had a similar problem. But they actually pulled it out of Windows Update within a week because there were systems that were hanging. There were systems that were bricking. If you think about what's going on, there's a bug in firmware on some of these devices. And this is a very rarely used code path. And if you hit this code path now as you're installing the revocation list and it breaks, that might be a brick instead of, a reinstall.
Well, because when you do the UEFI updates or BIOS updates back in the day, what does it tell you? Like, please don't turn off your computer while you're doing this, right? Because you're basically writing to a sock, right, on the motherboard. And if you get halfway through, just like with IoT devices, we can break stuff all the time. Now you're just in the state where the code update is incomplete and you've got a brick. Now it doesn't work at all. If you think about it, the CPU is going to come out of reset and run whatever's there. If you half updated what's there, you're going to get half of what it's supposed to do. Right.
Which is a brick.
Yeah, no,
that's
John,
what's happening.
That's an interesting question because on IoT devices, right, I would try to reflash via some other means, right? Or like if you really screw it up bad, you got to interface with the hardware via something like JTAG and basically rebuild everything that's on the flash. And there was a path to do that. Can you do that on I've never done it on a PC.
I can do it because I've learned.
Yeah. Well, you used to work for Intel, right? Yeah.
The folks on our team can do it because this is how we do a lot of our demos. But I wouldn't recommend it for most people. It's not fun if you aren't having fun with it. Like if you're a hacker and you really like this stuff, that's cool.
But is it JTAG on an Intel PC motherboard?
You can do something like JTAG, but that's not really the way that you'd probably do it. You'd probably take a SPY Flash programmer and a clip and just clip it on the right SPY Flash part that's sticking out on the motherboard, and you just eventually learn how to find those.
I got
through the thing and clip onto it.
Because that stuff is JTAG, and that stuff is not meant for the end user.
There is something like JTAG too. Actually, we published a different vulnerability a while ago now. Intel has something really cool where it's basically JTAG over USB. And if it's turned on at the right time and it's available, you can actually go and plug in a debug cable in USB without opening the chassis at all and actually debug the system through this USB cable, which is awesome.
It is awesome.
Unless you're doing something terrible.
Right.
Now, John, there was a similar boot issue with LG phones like the week before boot hole came out. Do you know any details on that? Was that a similar type of issue? It's more to the mobile device side, but it was interesting. We just had two of these bootloader issues back to back.
It's not the same because I believe that their secure boot process is different from UEFI secure boot. But in a theory, sort of, if you abstract UEFI and you think about, well, you're going to come out of reset and you're going to do some stuff. It's actually kind of similar because you're relying on that same sort of boot code that at some point has been checked and hopefully was done well. But if it's wrong, you're going to have problems.
Right.
And
like Apple jailbreaks, John, are
all those jailbreaks are like this.
Based on what we're talking about, like basically, right, from my assessment of those,
folks did the similar thing with the Intel ME. It's got a similar sort of story where you're going to have this sort of hardware-based secure boot. Below UEFI secure boot, you can put a hardware secure boot as well. So you can run all of this UEFI secure boot and root it into some fuses, basically, into some hardware that's immutable. And that's great, but it's like it's a foundation that you build on, and anything in the chain can break. Right. And that's truly what they call it, is a chain of trust.
Right. Yeah, and that was kind of the issues with the LG one as well, is a secure boot had the ability to break chain of trust and could introduce malicious code into the phones. And, this went back years. I think it was from phones from 2007 or something crazy. It was
that's interesting. Even if we take it a layer above UEFI, I was like, well, wait a minute. Isn't grub open source? And I had to ask that question because, I never went to the GitHub repository and looked at it. I just relied on the fact that there was this open source project that would boot my operating system and boot my kernel. I'm like, it's great. And I would read about grub and, configure it. Before that, it was Lilo. And both of those are open source. And I was like, wait a minute, John, if the vulnerability is in grub, that means they had to push a fix to it. So if you're looking at the commit history, you could see this fix. I'm like, wait a minute. You mean to tell me no one's looking at it, right?
So this is where it's interesting, right? Actually, I really have a lot of good things to say about the community here and what they did as we reported this to them. It was very cool that they went and, in addition to the bug that we reported, they went and found 4 or 5 other ones.
Oh, that's awesome.
And they fixed those too. And then they changed the process and procedures for how they sign these things so that they can handle this case a little better in the future. And that's the sort of thing that I guess for me, I see a lot of, examples, almost like a case study in this, what we did here, as something that's indicative of all sorts of firmware bugs, whether it's the jailbreaks that you guys are talking about or this or something else. You get certain key things. One is that it's a lot more pervasive than you think it should be, right? You're in one component, but it affects everything, just like here. A single sort of normal update process doesn't quite cut it. So just like here, where you have the OS update and then you have this firmware update in addition to it. And then the other thing is, a lot of times the updates themselves cause problems. And it was very funny to watch the very first couple of articles that came out about this. Some people called it from the very first time they looked at it and said, hey, this is going to cause problems just in the update. And they were right. It did. There are probably going to be some more problems before we're done. And that's the sort of indicative of this space. In my opinion, it's because people really haven't been looking at it. And it's really the attention of what we've been doing and operating systems and apps and networks. That's really moved the industry to be more mature across the board in all of those spaces. And this space has still sort of remained hidden. And that's changing.
But it's interesting, John, what I kind of get thinking of what you're saying is that many of us in security or even outside of security rely on a piece of software that very few people are interested in writing, maintaining, and scrutinizing. I mean, the vast majority of folks in technology and security just take it for granted that Grub's going to boot my kernel, right? And they just never bother to go, even look. And, thanks to you and your team at Eclypsium for looking at that. And thanks to the Grub team, too. It was by no means a knock on the Grub team for doing that, because most of us, we've got other things to do, and I couldn't even. I'm not interested in going and looking at the code. I am interested to look at it, but not to be like an active maintainer, right? So props to those people for wanting to do that, right?
But it introduces a very interesting software supply chain concern too, is because now you're using a piece of open source to boot your operating system. How secure is the supply chain in the commits that are going into that open source piece of software that we just instinctively take for granted and say, yep, it's going to do it? But are there other vulnerabilities or other backdoors embedded in that through this open source project that creates other issues? And that goes back to the whole supply chain issue.
It does, and it's not just the open source part. I mean, we can talk about Heartbleed the same way, right? Everything that you said really applies there just as much. And maybe that was one of the first times that everybody really started to figure out just how many things are dependent on one little open source project that you thought was a little thing, and it really isn't.
And John, that's really interesting.
There's another case.
Well, because we look at web app frameworks, right, or programming languages and libraries. So you've got Python, you've got Ruby, you've got JavaScript, you've got Lua, you've got Golang, and so the diversity. I don't know if it was Dan Gear or someone else that pointed out, right, the ubiquitous nature, right, of these inherently makes them more secure. But there are these smaller or pieces of code that are the backbone of much, much more widely deployed software. Because I'm pretty sure, I don't know what the percentages of Linux distributions that are using Grub or Grub 2, right? It's got to be in the 90, I would guess, 90+%.
Most of the ones I've heard of,
right, are using Grub. Before it was Lilo, then we moved to Grub, but they were all basically dependent on this one piece of code, and that was a commonality. When we look at languages like that, we don't find a lot of those commonalities because it's very diverse. In this case, we're pointing back to this one piece of code in software, which is scary.
Similar things do happen with libraries and like with Heartbleed, for example.
Yeah, SSL is a great example.
And
Open
those are
SSL,
the same.
right? Yep.
It's like the same problem again, right? You see that you just sort of overlooked this one library that everything else is going to be dependent on. And a lot of times folks don't actually think about firmware updates the same way, right? We're paying lots of attention to our OS updates. With things like the F5 and the Citrix stuff that happened recently. Actually, this has been a really interesting last month or so in terms of vulnerabilities and patching stuff. But if you think about some of those, a lot of the things that are getting attention right now are the things that traditionally have been easy to overlook because it's an appliance. It just works. And that's the point. That's why you bought it. But the problem is, it under the hood is just like every other computer, and that's same deal going on here with Grub and Secure Boot, because Secure Boot was introduced right around 2012 and became the default ever since. And so now you've got a whole lot of stuff that's sort of got that built in and it's using it, and you'd like to rely on it, but you end up with trouble like this.
And it's interesting when we take this problem over to IoT devices. And I was struggling to recall from memory all the ones that exist on IoT devices. OpenWRT actually has a really good page that kind of goes through the ones that I was familiar with when I was doing a lot more with IoT, right? So U-boot is one of the more common ones, right, on IoT devices. But then now I remember, I'm reading from the page, Red Boot was one that I saw, which is a different bootloader. CFE was yet another one. And BRN boot was like I think that was a Broadcom thing, right? But
you're really taking me back on some of these,
right? And you read through this page,
been a while.
and there's tons of them, right?
I think Alpine. I was looking because I was thinking, well, Alpine would be one of the exceptions in Linux, and it looks like they use like a syslinux bootloader instead of grub, for example.
One. Yep.
So because that was the first example I could think of in Linux that would use it, potentially use a different bootloader.
But embedded operating systems will use different bootloaders, and the other difference there is you're writing the bootloader to the flash as part of the firmware, right? It's not as tightly
the whole OS while you're at it, like
and the really kernel and the whole operating system and the file system is one package, and that's why we call it firmware, right? Because it's software and hardware, kind of the middle ground, right?
That's how some of them end up to be affected, by the way. Right? Yeah, like a lot of those now, especially a lot of network devices, the smarter, like very configurable things, they turn out to be like an Atom SoC from Intel.
Yep.
And it turns out to use UEFI, use Secure Boot, and they just write the whole file system and everything down to some flash chip on the same board. And it's really small, really lightweight, maybe fanless.
Right,
all these things are great.
These
same effect.
Bootloaders in the firmware, they don't. It's like the BIOS and UEFI and or UEFI and the bootloader kind of in one, right? In certain circumstances, right? Yeah.
It doesn't have to be, but it absolutely could. You used to have this idea of multiple stages, and you can translate that into UEFI as well, where you have sort of like your stage one, and it might be in one place, and it loads stage two, and then it loads the actual kernel image or something like that. Same idea can go on. You could have your stage one be like the shim in Linux.
Right.
Stage two could be grub, and then it's going to load the kernel. There's other ways of breaking it down too, but the idea is in a secure boot process, your chain is supposed to validate each of those things before running it.
Right.
Any buffer overflow, any sort of code execution vulnerability, anywhere down that chain, and the whole thing's done.
Breaks the chain of trust.
NVRAM that stored some of the metadata that told it how to boot, and you'd often look in the bootloader to get when you're reverse engineering firmware to get some of the offsets to see where it actually was trying to boot the kernel. That would tell you where the kernel was, maybe what kind of kernel and things like that. Yeah, and
the configuration of it too.
Yes.
So as you start to poke at that, you start to see just how this is the tip of the iceberg. Like this is one buffer overflow in one piece of that huge foundation. And as you poke at all the different configuration, settings that you might be able to change, and who knows what will be the outcome in terms of behavior for the system, you get to this, what we would call in the high assurance world, secure initial state. And there's usually a big assumption on secure initial state. And that turns out to be a really interesting base to play if you're into security research. Now you can sort of see all the other stuff that we do at Eclypsium just by sort of just thinking about what all the other places are. And we're trying to actually go in and look at those. If you think back to, why I would say that this one is reminiscent of security, sort of firmware security bugs in general, it's because of this. You can go poking at any one of these things. One bug is all it takes. And as soon as you have a bug, you've broken the whole chain.
Right.
And all the chain of assumptions is sort of crashing down. And it turns out that the updates very frequently break things even further, just because it's so many assumptions.
Yes.
And it's hard. I actually am not faulting that. I used to work on some of these things myself. I get how hard it is. And I'm not saying that people should do everything perfectly. That's the point. What we're doing is introducing monitoring on top of these things, so that even if the fixes aren't available, you can actually detect and sort of kill the dwell time of a attacker that's leveraging something like this, and be able to sort of root it out by monitoring and detecting what's anomalous, which is sort of one of the sort of workarounds that we've been recommending on this one. We know that it's going to take a lot of time to go test all of these systems for the updates and all of that. So the important thing, I think, for folks to think about as an immediate action is really to just look at the contents of the boot partition. Look at the integrity of those files. What's there? If you're getting weird stuff that you didn't expect to see, that's something to go look at. But generally speaking, most systems will have the same bootloaders with similar configurations, or at least the administrator should know what those configurations are.
Right. Matt?
I was going to say, I mean, if we think about this from a vulnerability management perspective, right? We've gone through the evolution of device-based vulnerability management, really going after the operating system. Then we kind of morphed into application vulnerabilities and various layers of the app and the vulnerabilities there. We haven't paid much attention to the firmware and the hardware vulnerabilities that a lot of these other vulnerabilities potentially sit on top of. Because Jeff
add that to your risk model when you're looking at ransomware.
You've got it.
What if it embeds it in, right? So it's not just your vulnerability management, but your entire risk assessment of your organization. You have to run through those threat models to go, what if ransomware exploits a bug like multiple bugs like boot hole, and is just constantly now your remediation, right, and your impact of ransomware is even worse, because I can't just rebuild the operating system.
I got to rebuild the whole system.
UEFI. I got to go update UEFI, which
I'm going to buy hardware.
It typically means either I got to buy hardware or I got to have physical access to every machine. And back to your point, everyone working from home. That's
and I hope you know how to use a spy programmer. All of that stuff.
Exactly. Well, because Jeff was asking in the Discord, where does this fall in compliance requirements? Does it fall under vulnerability management? Right.
It is a good one.
I'm thinking that I was sitting here thinking about this, going, wait. We think about vulnerability management as OS vulnerabilities and third-party patches and OS patches and maybe applications. How many people in their VM program are thinking about firmware, hardware-based vulnerabilities, and how do you address those as part of a broader VM program?
That's a great question. And one of the things that I've spent actually probably a little too much time trying to figure out as I've been mapping what we do into different compliance requirements and trying to plug that into a program of what you would actually do. And one thing that I've noticed, and I sort of used to work in an area where we would write these requirements, so I kind of get what they're doing. A lot of these are really nicely worded, where they use some big, broad terms that totally include this stuff, but they have no idea how to do it. So, for example, a lot of the NIST 853 stuff will say software and firmware in a lot of requirements. Particularly around flaw, you could think of flaw remediation being applied at all these levels, and nothing about it says that it should be limited. It's just that nobody does it that way. Same sort of thing if you look at SI7, right, where it's talking about integrity. Well, they talk about explicitly software and firmware integrity. Cool. So the requirements kind of include this, but nobody's been doing it for many years, so nobody knows to look for what to do in this program. So what we actually did is we said, okay, I see how I can go and detect a bunch of specific things, and I can map that back to the requirement. So now I know what I can detect, and I can map that as evidence against these controls or requirements. Now 853 becomes the lowest common denominator. You can find mappings from like PCI to 853. You can go to CMMC at 853. You can go to all these different compliance regimes, and 853 is supposed to be like the master list of controls. So I started there, and I took our detections, whether it's a specific vulnerability that we were looking for. A lot of those are like least privilege problems in the end of the day, or maybe access control problems. And you can just map that right back into the control in 853. And then it becomes evidence when you see a scan that shows you do or do not have that vulnerability. And that's the way I would do it from a compliance perspective. But then there's another question from the vulnerability management in terms of like patch management perspective. And from my perspective, you got to be a little careful with actually deploying a lot of patches. We saw this with Meltdown Inspector. We saw that sometimes patches don't go the way you'd like them to. In general, they are usually pretty good, and they're the best you got most of the time. But sometimes the best you got is you don't got anything, because there are times where you don't even have an update for these issues. And it does actually take manufacturers and the community of different supply chain, providers, suppliers. It might take them months to actually get something out there that'll help you. That's why we kind of use this idea of monitoring as a compensating control. And you would look at, well, maybe I can't patch this system. Maybe it actually can't go down. I can't reboot it. Or maybe it's that there actually isn't a vulnerability, or there isn't actually a patch for the vulnerability at all. In those cases, you don't have a lot of choice, but you can introduce this other control of monitoring. And that's sort of the approach that I like to take. I try to eliminate single points of failure when I can, and try to look at multiple different ways of getting at something.
Yeah, I mean, Jeff might disagree that why using this 853 when PCI is the perfect compliance requirement, but I argue with him on that all the time, so I'll take your 853 answer.
I think the point is, compliance versus security aside, right? Like, this is an issue we need to look at. John, it's very eye-opening when you come on the show, our shows, and talk about this particular issue, because it's one of those things that really truly does fly under the radar, right? And I think we evangelized it in the IoT sense. John, what you really brought to the table was, you don't really have to have IoT devices to have this problem. It's built into every, computer that you're running, essentially, physical hardware. And you need a system to be able to tell you what, even like we were talking about this actually with Faro, right? And web application scanning is like, step one is to be able to enumerate what you have, right? And in this case,
exactly.
You've got all these subsystems in this software, and that's step one. And step two is to start to look at some of the risks, right? And not have false positive and false negatives in determining, I think, John, for me in this case, it's do I have vulnerabilities in my various firmware or subsystems? And number two, am I running something that's trusted, right? And then what's that relationship? Another thing, right, between my operating system and that firmware, what's the direction, right? Someone gets on the operating system, can they plant something in firmware, or vice versa, right? Someone paints the firmware, can they get into the operating system?
Exactly. A lot of people will think about this as a physical attack vector, and for sure, that's a big hammer. It'll work. Yeah, but it turns out that there's a lot of software interfaces too. Those work as well.
Exactly right. Yeah.
So folks that want to learn more can visit securityweekly.com/Eclypsium. Contact them for a free trial. I strongly encourage everyone to work this into your vulnerability management programs and understand what's going on in all your systems, because it's truly, I think, an exposure that most of us aren't paying attention to. So, John, thank you so much.
That's why we're here. Hey, thank you very much. Always a pleasure with you guys.
With that, we'll take a short break, come back, and cover the enterprise security news. Stay tuned.